Okay, let's talk about finding intercepts and asymptotes of rational functions. So x-intercept, to get an x-intercept, I set y equal to 0. So I end up with something like this. Now mathematically, I multiply both sides by the denominator. 0 times anything is 0, so I end up with this. Hopefully that does not make sense to you. So what that's telling you is there is no x-intercept, okay? And once you get doing a lot of these questions, hopefully you realize that the only place you need to look to find information about the x-intercept is the numerator. So you really just need to say to yourself, what is going to make the numerator 0? And hopefully you say nothing for this one. Having said that, there is one case that you need to consider. You need to consider if there was ever a point of discontinuity. So if you look at the top and you have an x-intercept and a vertical asymptote on the bottom, then that's the one time you have to also look on the bottom to talk about x-intercepts. That's a rare occurrence. So you just need to look at the top. So y-intercept, set x equal to 0, so I have a y-intercept of 2. Okay, asymptotes. So my vertical asymptote is very simply what is going to make my denominator 0. So x equals -1 is going to make my denominator 0. If your denominator is not already factored, maybe it's a good idea to just factor it quickly. And my horizontal asymptote, I find the limit as x approaches infinity, and how I do that is I divide the entire function through by the highest power of x in the denominator. So I look to the denominator, the highest power of x is x, so I divide the whole function by x. I simplify, and then I actually plug in infinity. Anything over infinity is 0, so this part 0. So when I plug in infinity, I get 0 divided by 1, and 0 divided by 1 is 0. So I have a horizontal asymptote at 0. If you're doing a question like this, and you get a horizontal asymptote, 0 or any other number, that means there's no slant asymptotes. You don't need to check that, okay? This guy here, really quickly, I am going to factor the denominator first. So x minus 3, x plus 2. So I'm going to use what I told you about just looking in the numerator. What's going to make the numerator 0? 0. Okay, y-intercept, I set x equal to 0. I'm going to go back to my original here, so 0 over -6, so 0. Vertical asymptotes, what makes my denominator 0? So 3 and -2. Horizontal asymptotes, I need to evaluate my limit as x approaches infinity. So I need to divide through by the highest power of the denominator. Okay, so x over x squared over x squared, minus x over x squared, minus 6 over x squared. You guys can't see this anymore. So 1 over x over, there we go, 1 minus 1 over x minus 6 over x squared. We plug in infinity, and remember anything over infinity is 0, so I end up with 0 over 1. So again, my horizontal asymptote is 0.